So what I would like to cover today is the setup of a basic anaesthetic machine. There are different machines within the practice. Some of them are quite sophisticated and they have their own setup instructions, but this is one of the more basic ones, and I just want to go through some of the sort of really important steps that you should take before you're happy that an anaesthetic machine is ready to use and is safe to use. So this is a Penlon machine, and the first thing to do is to just generally look at the machine, make sure that everything appears to be clean and in place and there aren't bits sort of hanging off. Then the next step is to make sure that we have a proper backup oxygen supply. So if you look on the back of the machine, you will see that there is one size E oxygen cylinder, which is our backup supply should the pipeline supply fail. So we need to make sure that we have enough reserve in this cylinder if our main supply fails. So I've turned the cylinder on, and we then need to look at the pressure on the cylinder dial on the front of the machine, which should be around about 137 bar. So we can see that cylinder is full, so we have sufficient backup supply should our main supply fail. The next most important thing to do is if we turn this cylinder off, we can then check that the oxygen failure alarm is actually working. On this machine, to get the gas to flow, we have to switch on the gas delivery switch here, so that just goes to on, and you'll see the flow meters actually light up. The other thing to notice is that this little green button here will change as the pressure drops. So I'll turn on the supply, the oxygen supply. We'll set a flow of about 4 litres a minute. You can see the pressure in the machine dropping because the cylinder is turned off. And once this reaches 0 and our flow starts to drop, then we should have an audible alarm to show that the oxygen supply has failed. The other thing that will happen is, so there's the alarm, the other thing that will happen is that this green button will change to red. So we have both an audible indicator and a visual indicator that the supply has failed. Okay, so we've checked our backup supply. The next thing to do is to plug in our pipeline supply. So on this machine we have oxygen and air. We don't use nitrous oxide anymore within the practice, so we only have to worry about these two. So the oxygen supply plugs into the socket on the wall. These are colour coded, and they're also different shapes for the different gases. So it is impossible for me to plug the oxygen pipeline into the air supply. So I'll plug that into the oxygen, so you push and then tug to make sure that that pipeline is in properly. And we can do the same with the air pipeline. So that will plug into here, and we can give it a good tug to make sure that that is in securely. We can check our pipeline supply here. So this is our oxygen pressure, which should be just over 4 bar. So we can see our pipeline pressure is fine. And we also have a pipeline pressure for air, which is also fine, so that's around about 2 bar. And again, so we just check, turn our flow meter to make sure that the bobbin on the flow meter can move freely and doesn't stick. On this machine, you can see we have what are called cascade flow meters. So the far left flow meter measures oxygen flow between 0 and 1 litre, and the next one in to the right of that indicates flow between 1 and 10 litres a minute. We can do the same with the airflow meter, just to make sure that is also flowing freely and that the bobbin within the flow meter is not sticky. One other point to make with this machine is that there is a switch down here which allows us to use either air or nitrous oxide. We can use one or the other. So we would have it down if we had nitrous oxide, but of course that has now been taken away from the practice because of its sort of health and safety concerns. So that switch should always be moved up to the air position. So that's our gas supply, which is secured, and we are happy that the machine will be delivering enough oxygen. The next thing is to look at the vaporizer. We need to make sure that that is adequately filled for the next anaesthetic, so the isoflurane level should be just at this line. We also need to make sure that the vaporizer is secure on the back bar and is locked. If I take the vaporizer off for the moment, you can see there is a switch here. So if I seat that back onto the back bar here, that feels secure, but we do need to remember to push that lever so that the vaporizer is locked into position. The next thing to do, the final check that we need to do on this machine, is to switch our oxygen flow back on and to occlude the outlet just to make sure that we don't have any leaks. So we're just going to put my thumb over there and we can see that the flow drops as I occlude the flow. And then you may be able to hear, as the pressure rises within the machine, a pressure relief valve opens at the back of the machine to stop excessive build-up of pressure that could damage some of the components. So if I do that again without speaking, then you may be able to hear it. There we go. So, fairly straightforward machine, and those are the most important checks that you need to make before you can say the machine is safe and ready for use. Okay, so the next thing I want to do is to go through checking the breathing systems, and in theatre we tend to use either circle systems or the T-piece. So if I run through the T-piece first, so this is a modified T-piece. That would be a standard, the original T-piece without anything on the end of this sort of expiratory tubing. The modified one has a bag and a valve attached to it as well. So again, just look at the system, make sure that it looks intact, and make sure that all the parts are connected properly. When you connect anything like this, then don't just push it on. What you need to do is to push and to twist at the same time, and that will lock it in position. Same with the bag, push and twist, and the same with this valve on the top. So we need to just push down and twist, and that will lock them in position. So the next thing to do is to make sure that there are no leaks within the system. So if we plug the delivery tubing into the machine, we need to close that valve. So turn fully clockwise, so righty-tighty, lefty-loosey, or something like that, but fully clockwise to close the valve. And then if we occlude the end of the system with our thumb and turn on a flow of around 4 litres per minute of oxygen, and you can see the bag is filling, and if we close the flow off, there shouldn't be any any leakage from this bag if I compress it. So that feels quite tight, there's no obvious leak. The thing to remember with these valves, because these are used in small animals, is that there is a safety system in this valve, so that if there is too much pressure building up, then there is these valves will open to prevent too much pressure being applied to the animal's lungs. So if I actually squeeze the bag too hard, then you can hear that there is a leak. That is quite normal. It's just the safety system in the valve operating. But if I just fill the bag and gently squeeze, there shouldn't be any obvious leakage. There shouldn't be any collapse of the bag. So I think we can say we're happy with that system. There's no obvious leak. And then we can open that valve and squeeze the bag to make sure that the gas is coming out properly. So it's a fairly simple check with the T-piece. There's not very much to go wrong apart from the valve or maybe a big hole in the bag where you have a leak. So that's fairly straightforward. So that is the T-piece. The other system that we will use in theatre is the circle system, which is a little bit more complicated. The first thing to look at with this system is the granules inside. So this is classed as a rebreathing system, so it means that we can reuse some of the gases that the animal has just exhaled. To do that, we need to remove all the carbon dioxide from those gases. So the granules are soda lime, which will absorb the carbon dioxide, and as the granules become exhausted, they will change colour. In this case, the soda lime is changing from sort of a cream colour to purple. If you see that half of the granules have changed colour, then the whole of the soda lime needs to be changed. In this case, as I say, only a little bit has changed, so we're fine to use this for the next patient. So it attaches to the machine by this connection. And then we have two different types of tubing, which you can see they differ in diameter. So the smaller tubing we would tend to use in animals up to 10 kilograms body weight, and the bigger tubing in animals over 10 kilograms body weight. So I'll use the smaller tubing, and we will plug those into both the inlet and the outlet from the circle system. Again, push and twist to make sure that these tubes are locked and they're not going to fall off. So they're securely fitted. The same thing as with the T-piece, I'm going to close that valve and occlude the end of the tubing with my thumb, and then I'm going to use the flush, the oxygen flush here, to make sure that the bag fills up. Oops, just occlude this end properly. Okay, so we just need to squeeze the bag to make sure there are no obvious leaks within the system. So that bag doesn't feel as if it's collapsing, so we can say there are no leaks. And once we're happy with that, we can open the valve and then squeeze the bag to make sure that the valve is working. So that system, again, we can say is safe and ready for use. So when we're using anaesthetic gases, there will always be some spillage from the exhaust valve on the breathing system that we're using, and it is really important that we don't become exposed to those waste gases. So we do need to scavenge, which is fed into a system that removes or sucks away all of these waste gases and actually takes them into the air outside. So there is a connector here, so there's a piece of tubing that connects to our There's a piece of tubing that connects to our exhaust valve on the anaesthetic machine, and that you need to make sure that that is plugged in properly to the outlet on the wall. There are slightly different outlets depending whether we're working in theatre or whether we're working in diagnostics or in the induction area or X-ray. But in here, basically, the tube just plugs into this connector on the wall. The other important thing to remember with the scavenging is that if we're using a capnograph as a monitor, this is going to suck out, this capnograph on the machine is going to suck out about 150 mils of gas per minute for analysis within the monitor. Once the gas has been analysed, it then just gets pumped out into the atmosphere or into the room. So it's important that we also scavenge from the capnograph. So when you're setting up, it's really important that this tube coming from underneath the monitor is also plugged in to this connector close to the exhaust valve, so that all of the waste gases from the capnograph are also fed into the scavenging system. Otherwise, after an hour or so of anaesthesia, we will start to smell anaesthetic gases within the room, and in the long term, it really doesn't do us any good at all. So, so that is another important thing, that you need to make sure that this tubing is connected not just to the connector close to the exhaust valve on the breathing system, but also to the exhaust outlet on the monitor.